Today I'm going to be learning how to be a materials engineer. So this is a list of 16 common properties that has been split into pairs of opposites. Strong and weak. Strong, like brick. Weak, like paper. Flexible, rigid. Flexible, bendy, like rubber. Rigid, not bendy, like steel. Hard, soft. Hard is like steel. Soft is like wool. Heavy is like a lead weight. And light is like a feather. Smooth like a marble. Rough like sandpaper. Transparent, something you can see through, like glass. Opaque, something you can't see through, like wood. Conductor, a conductor allows electricity or heat to flow through. Copper is good for both of these. Insulator, does not allow electricity through, like the plastic that covers wires, or doesn't allow heat through, like wool. Waterproof, keeps water out, like plastic or rubber. Absorbent, soaks up water like tissue, paper, fabric, or a sponge. I'm testing the strength of these 5 materials. Paper, a key, eraser, popsicle stick, and a water bottle. Now I'm going to make a hypothesis to see which one will tear, stretch, squash, snap, or bend.
Okay, so let's start with your paper first.
Can I tear it?
Yes, you can.
Yes, so I'm correct on that one.
Can you stretch it?
Nope.
Okay.
Can I squash it? Squash. Maybe not. And then let's see.
Well, you can squash it. Go like this.
Yeah, so I can squash it. And can I snap it? I don't think I can snap it.
Okay.
Let's see if I can bend it.
Okay, so your hypothesis were correct about the paper. It has different strengths and weaknesses, right?
Okay.
You definitely couldn't stretch it though.
Mm-hmm.
Okay, next is our wood. Can you tear it?
Nope.
Okay.
Can I stretch it? No.
Okay.
Let's see, can I squash it? No, I can't. Can I snap it?
Oh, yes you
I
can. How about bending it? Probably should have tried to bend it before you snapped it.
Probably. But I'll just use this part.
Okay.
No, I can't bend it without snapping.
Yeah, okay.
So that was correct too.
Hey, what's your next material? Metal.
Key.
It's metal, right?
Metal. So I can't tear it, I can't stretch it, I can't squash it, I can't snap it, and I can't bend it either.
Can you not bend it at all? Try bending it. Okay, metal's pretty strong, huh?
Yes,
and always.
So I got, my hypothesis were correct. So now
Okay, what about plastic? Can you tear it?
No.
Okay, can you stretch it?
I don't think so.
No. Hold on, let's try this one last so you don't ruin it.
Okay.
Can you snap it?
No.
What about bending it?
I think
You can definitely bend it.
but it goes back to its original shape.
Yeah, but you can bend it. So let's put an X on bend, because you can bend it.
But this was just my hypothesis.
Yeah. Okay, now squash it. You gotta take the lid off to squash it. Okay. Now our last material is rubber. You're using an
Rubber.
eraser.
I don't think I can tear it. Maybe I can stretch it.
Can you stretch it out at all? Okay. What about squashing it? What about snapping it? But you can bend it, right?
Yep.
Okay.
wider columns. So now we gotta see.
You're gonna need to put that on the bottom. There you go.
I can hold it for you, though. It has a
25 inches. These ones are not as straight, and so I can't do another one. So it's only this one. 11.5 inches.
Okay.
Diagonally, and I had to put these in because it wasn't balanced. And I put this one on top to make it tall.
Okay. Measure how tall it is.
Inches.
18 inches. So which was your tallest tower?
My first one.
The first one. Why do you think that it was successfully your tallest tower?
Because it had more sturdy, thicker bases.
Okay, so these
Thicker.
wide. So these ones were taller, but they weren't as sturdy, right?
Yeah, I would have had to make a new one.
Yeah. Cool.
I'm learning about friction. It's the force that slows objects down. So I'm going to push this car on different materials and see which one has the most and least amount of friction.
I want to try this tire. Oh my! That is so big.
About 205 inches.
Okay.
Concrete.
All right. Okay, measure how far that is.
Mom, I found that! Mom, I found this!
Did you find a dandelion? Whoops, Archer, straighten up, Archer. So you go where the car is. Slide over, Archer. There we go.
Mom, I need to break it. Oh
150 inches.
no! I actually...
All right. Okay, go ahead and measure. Now scoot it over, Archer, so it's in where the car is. Oh.
In the end, the car went the farthest on the tiles. So the tiles have the least amount of friction.